Welcome, my friends. In this lecture, we'll explore the generic repository pattern in C#, a powerful design pattern for data access. Our work is divided into two parts. First, preparing general files, and second, specializing the patient service. Part 1 involves setting up core files and structures, including the generic repository and foundational interfaces for common operations like add, update, delete, get all, and get by ID. For Part 2, we'll create a dedicated patient repository, focusing on patient-related operations for better organization and scalability. We'll start by structuring our project into layers, organizing the medical clinic system for clarity. Imagine developing a clinic management system with tables like patients, doctors, class. Simply define the template in the interface and then apply it to any class when needed. Get all records from the table. Task enumerable of tget all async. The purpose of this function is to retrieve all data as it will be called from another class. Search or filter with a custom condition. Example: get all patients whose age is greater than 30. Task enumerable of t. Find async with expression. Add a new record to the table. Task add async t entity. Update an existing record. Void update t entity. Remove an existing record. Void remove t entity. For example, patient repository implements iRepository and LT, patient and GT, to manage patients, doctor repository manages doctors, and appointment repository handles appointments. Explaining each method in iRepository. Get by ID async. To purpose, retrieve one record by ID example. Get patient with ID equals sign 5. This query in SQL equivalent. Select all from patients where patient ID equals sign 5. Get all async. To purpose, retrieve all records. Example: get all patients in the system. This query in SQL equivalent. Select all from patients. Find async. To purpose. Filter or search with conditions. Example: get patients whose names start with A. This with SQL select all from patients where first name like A%. Add async. To purpose. Add a new record. Example: add a new patient. This is equivalent to the query in SQL. Insert into patient's first name, last name, values Ali and Omar. Find async. Purpose search for rows based on a custom condition. Uses lambda expressions to build queries. Example: patients equals signer with underscore patient repository dot find async first num dot starts with A. This retrieves all patients whose names start with A. Add async. Purpose: insert a new record into the table. Why async? Database writes may take time, so we use async for performance. Example: await underscore patient repository dot add async new patient first name equals sign Ali, last name equals sign Omar. Purpose: update an existing record. Why not async? Because entity framework core tracks changes internally, and the actual save happens only when save changes async is called. Example: patient dot last name equals sign Hassan. Underscore patient repository dot update patient name. Next, we can see how a specific repository like patient repository inherits from this base repository key and extends it with custom methods. So far, we have finished the first part of the lecture, and God willing, we will meet you in the second part of the lecture to allocate patient service in a private repository, customizing the patient service with the repository pattern. Welcome to the second part of our lecture, focusing on customizing the patient service with the repository pattern. We'll create a dedicated repository specifically for patients, building on our previous discussion. In the first part, we built a general repository with common functions like add, update, delete, and retrieve, which entities can inherit. Now, we'll apply these foundational concepts to the patient repository, tailoring it for patient-related operations. Instead of writing all patient database operations directly in the controller, a dedicated repository is far superior. This patient repository becomes the single, authoritative place for all patient data operations. This approach champions the principle of separation of concerns. The controller focuses solely on request handling and returning responses, keeping its responsibilities clear. Conversely, the repository focuses exclusively on data access and queries, abstracting database complexities. This design promotes reusability and clean code. You write complex logic like get patient with appointments only once. This eliminates repeated SQL or entity framework queries, leading to a much tidier codebase. Furthermore, it ensures easier maintenance and testing. Changes to patient retrieval only update the repository, not the entire project. You can also easily mock the repository in unit tests, simplifying the testing of controllers or services. So, how does this work? First, define an interface, iPatient repository, for patient-specific functions. These functions could include examples like get patients by age or get patient with appointments. Next, implement the class patient repository containing the actual entity framework core or SQL logic. Then, register this repository in your unit of work, allowing you to simply call patients from anywhere. Finally, use it in your controllers, resulting in no raw queries, just clean and expressive calls. For instance, you'd write unitofwork.patients.getPatient with appointments async by ID, making your code highly readable. This structured approach significantly enhances code organization, testability, and scalability.